Welcome to Mrs. Miller's notes for her double block algebra class. These are the notes for a section that's not in your book, and it's entitled Geometric Sequences. And what we're going to do today is we're going to find a pattern and the next number in a geometric sequence. We're going to write the equation for the geometric sequence, and then when we're given a term, we'll find a given term for a geometric sequence. Now, if you look at this opening activity here, you're watching a ball bounce in this picture. You can see the path that the ball takes as it's bouncing. And you drop the ball from a height of 200 feet. So this is 200 feet up here. Every time it bounces, it rebounds to a height that's half of the previous bounce. What height does the ball reach after the fourth bounce? So we're starting with 200, and then you drop it, and it comes back up. It would come back up to 100, and then it would go down and come back up, and then it would be at 50. So they wanted to know how high it was after the fourth bounce. So this is the first bounce, second bounce. So this will be our third bounce here. That's going to be 25 feet. And then our fourth bounce after that, it's going to be 12.5 feet. So that would be how high the ball reaches after the fourth bounce. 1, 2, 3, 4. It's after the fourth bounce. Okay, so this is an example of a sequence because the ball is bouncing half as high every single time. So there you're either multiplying by a half or dividing by 2. So when you multiply and divide to go from one number to the next, that's a geometric sequence. So remember, when we've talked about sequences before, we've been adding or subtracting. And to get that sequence, it was a list of numbers that were in a particular order that followed a specific pattern. Now we were adding and subtracting before, now we're going to be multiplying and dividing. And each number in our sequence is called a term. And you have your first term and your second term, and they're called a sub 1 and a sub 2. If you had more terms, they would be a sub 3, a sub 4, etc., etc. Now a geometric sequence then is going to be a sequence in which each term after the first is found by multiplying or dividing the previous term by a constant. And that constant is called a common ratio. And we're going to call that little variable an R. So that's like your pattern that you're finding. So when the ball was bouncing and it was going half as high, that was the ratio, 1/2. So we're going to find that in some of our problems, or sometimes we might be told it. Okay, so let's try and do that for example 1 here. Let's try and find that common ratio, or the pattern. Let's find R. And remember, you have to go from one term to the next by using the same multiplying or dividing. So to go from 1 to 3, you have to multiply by 3. And then see if that works for 3 to 9. Yeah, 3 times 3 is 9. And 9 times 3 is 27. Okay, good. So that's our ratio there. We're multiplying by 3. And you can write it out in words like that, or you could put times 3. For part B, we have decimals. Don't be frightened by that. 8.8 to 4.4 to 2.2 to 1.1. You should be noticing that to go from the 8s to the 4s, you have to divide by 2. And then to go from the 4s to the 2s, you divide by 2. And the 2s to the 1s, you divide by 2. So here you are going to definitely be dividing by 2. Now, another way that we need to think of that is multiplying by 1/2. Multiplying by 1/2 and dividing by 2 are the same. And when we want to officially write our equation with a ratio, we want to write in the number that we would multiply by. So we have to be comfortable with thinking of dividing as multiplying by a fraction. Okay, for example 2, we're going to do the same thing. We're going to find that ratio and the next two numbers. So again, to go from your first term to your next term, you're either multiplying or dividing. Here the numbers are increasing, so we must be multiplying. So 2 times what is negative 6? That's negative 3. So let's try it again. Negative 6 times negative 3 is a positive 18. Times negative 3 would be a negative 54. So notice that the signs are alternating here. So that tells you that you're multiplying by a negative 3. And then we have to find the next two numbers. So we would take 54 times negative 3, and we would get 162. And then we would multiply that by negative 3, and we would get negative 486. So those would be our next two terms. Now in part B, to go from 256 to 64, we're decreasing. So that means we're dividing. Now, if you can't figure out what you're dividing by, take 256 and divide it by 64. That will give you the number you're dividing by. Or look down here at some of the smaller numbers. Okay? And maybe you know 64 divided by something that gets you 16. Or 16 divided by something that gets you 4. Every pattern should be the same. So you're dividing by 4 from number to number to number in this pattern. So then we'll have 4 divided by 4 is 1 to get our next number. And 1 divided by 4 would be 1/4. So yes, it's okay if you get a fraction or a decimal for some of your terms in your sequence. That's okay. Now, there's a pattern in the way that the terms of a geometric sequence are formed. And it's possible to write a formula for each term of a geometric sequence in terms of the first term and the common ratio. So this table here is a little activity we're going to do in class to help us figure out that equation that will help us with any geometric sequence that we come across. So let's just take a look at this first sequence here. We've got 2, 6, 18, 54, and so on and so on and so on. Now, this is our first term, so it's A1. Our second term is A2. A3 for our third term, A4 for our fourth term. Any term in there would be AN. Okay. Now the pattern, if we were to find the pattern, to go from 2 to 6, we'd have to multiply by 3. To go from 6 to 18, we're multiplying by 3. To go from 18 to 54, we're multiplying by 3. Okay? So our ratio is going to be 3, that common ratio. Okay? So we don't have to worry about that column there for that one. Now, if we want to express the number, or I'm sorry, express the sequence as numbers, it'll help us before we do it as symbols. So, if I am looking at my sequence and I want to express it as numbers, I know I have numbers up here, but I want to write it in a different form. So my first number is 2, and then to get the next number, to get 6, I took 2 times 3. And then to get the next number, I took 6 times 3. 6 times 3 was 18. And then to get the next number, I took 18 times 3. Okay, so that's how I got my numbers. Now, this 2, this is really my A1 term. So really I have A1 times 3. And my second term was the 6, so that was A2 times 3. 18 is really A3 times 3. But that's not really a good sequence because I have to know what the third term is before I can multiply it by 3. So we're going to tweak this just a little bit. Okay. Now remember this 3 is our ratio. So I could write this as A1 times R, A2 times my ratio, A3 times my ratio, and so on and so on. Now, okay, so now I can write my sequence as the first term times the ratio, second term times the ratio, third term times the ratio. But that's not really the best way to write it because I'd need to know what the third term was or the second term was in order to find, a specific term. So I'm going to tweak this a little bit. But before I move on, I want you to notice that my number here, this A1 that I'm multiplying by 3, this really gets me my a to the second term. And then when I take a to the second times 3, that really gets me my a to the third term. And this a to the third times 3 gets me my a to the fourth term. So the term that I'm using is really the number of the term minus 1. Okay, so if I'm trying to find my fourth term, I'm going to take my third term and multiply it by 3. So the number of the term minus 1 is what I want to multiply by 3. Okay, so again, if that's going a little bit over your head, that's okay. When we get to this final box here, we're going to have the equation, and that's what we really need to take away from this. Okay, so I'm going to modify this just a little bit. Okay, I have my a to the first term. I'm going to skip him for now. Let me switch colors here too. And now for this second term, I had it as my 2, that was my A1. A1 is 2, times my ratio, which was 3. And I can also write 3 as 3 to the first. So I'm going to put a little exponent in here now. Since I'm going to write this sequence as symbols, I'm going to add another little symbol in there. I'm going to put a little exponent. Okay? And really here for this next one, I would take my ratio, but I would, let's see, if I'm doing 6 times 3 times 2, okay? I'm still multiplying the 2 by the 3 to get the 6. So the 6 is really 2 times 3, and then timesing by that 3, which was my ratio. So really I have 2 times 3 squared. And then up here to get the 18, I took 6 times 3. Well, the 6 was 2 times 3 times 3, and then another 3. So this is really 2 times 3 to the third. So notice here I'm putting these exponents in. So I've got a 3 and a 2 and a 1. So over here to get my first term, that would be 2 times 3 to the 0, because those exponents are decreasing. And those exponents now are representing the number of the terms. So anything to a power of 0 is 1. So 2 times 1 is just 2. That was my first term. And then 3 to the first is 3 times 2 is 6. So that's what I got here. And then 3 squared is 9 times 2 is 18. That's also what I had here. So it's just another way to symbolically represent the multiplication that I was doing to get each term. So now I have a little bit more structure here. And it's pretty much the same structure for every single box in this chart. Okay, all of them have a 2 to begin with, so that was my A1. That was my very first term. So my very first term. And all of them have the 3, which is, oh no. Okay, And all of them have the 3, which is the ratio. So the only thing that's changing is that exponent. So I'm starting with a 0, and then I'm increasing to a 1, and then a 2, and then a 3. But again, this is my first term. So for my first term, I have an exponent of 0. For my second term, I have an exponent of 1. For my third term, I have an exponent of 2. For my fourth term, I have an exponent of 3. So again, it's that whole n minus 1 concept. So if I want to write a generic equation now, let me write it in red. Here we go. I'm going to start with my a sub 1, my first term, times my ratio. But then I'm not going to put a number up here for my exponent. I'm going to put the n minus 1 because it's the number of the term that I want to find minus 1. So this is the equation that we're going to use whenever we're finding a geometric sequence. So to find any term in a geometric sequence, we're going to use this formula. Or if we know that term, we're going to use this to help us write an equation for it, or to find the first term, or the rate, or whatever. So this is the equation. So if that stuff in the chart was a little over your head, that's okay. Just wanted to explain it to you and show it to you like we did before for the algebraic sequences or the arithmetic sequences. So now we're going to use this, okay? And A1, that's going to be our first term. The R, that's going to be our common ratio. Whoops, I had to put an N on the ratio. Okay, that's going to be a ratio. And then the N up here, that's going to be the given term that we want to find. All right, so most of the time, for example 3, we're just going to leave the n as an n. When it says write the equation for the nth term, that just means that you want to leave an n as an n in your equation, but you should be able to find the r, and you should be able to substitute in the first term. So we have to find the r, we have to find that ratio. So to go from 3 to 12, you multiply by 4. To go from 12 to 48, you also multiply by 4. 48 times 4 is 192. Okay, so that's my common ratio then. I'm multiplying by 4. And my first term, they told me that was 3. That's the first term in my sequence right there. So then I'm going to put that together in this generic equation up here. So I'm going to leave the a sub n just as an n. My first term is 3, and my ratio is 4. And then I'll have the n minus 1. There's my equation. So now if you told me to find the 50th term, I would put 50 in for n, and then I would simplify that expression. My n was a little sloppy there. Let me fix that. Okay, so let's try it again. Now my numbers are decreasing here, so I have to figure out what I'm dividing by. So to go from 40 to 20, I have to divide by 2. From 20 to 10, I'm also dividing by 2. 10 to 5, I'm also dividing by 2. And the numbers are staying negative every single time. So I'm not alternating signs, so I know I'm not dividing by a negative 2. So my rate, or my ratio then, is going to be dividing by 2. But since I'm dividing, I'm going to write it as timesing by a half. Okay? We have to use a fraction when we're dividing. So multiplying by 2 is the same as, dividing by 2 is the same as multiplying by a half. And my first term was given to me. That's the negative 40 right there. That's my first term. So now I'm going to write my equation. A sub n equals my first term, the negative 40, times my ratio, or my rate, to the n minus 1 power. So I think these equations are a lot easier to write than the arithmetic sequence ones. But since we've had exposure with the arithmetic sequence ones, these should be fairly straightforward too, maybe even a little bit easier this time around. Okay, example 4, a little bit more of an application. It says find the first 5 terms of a sequence. Now, they tell you that the first term is 243, and then they're telling you that your ratio is 1/3. So you're going to multiply by 1/3 to get your next term. So 243 times 1/3, or dividing by 3, is going to be 81. And then you times by 1/3, or divide by 3, and you get 27. And then you get 9, and then you get 3. So there's your first 5 terms. Now, if we kept going, we would get 1, and then 1/3, and then a 9th, and then a 27th, and then 1/81. Okay? Does that look familiar? It kind of looks like those table of values that we were doing with our negative exponents and how the y values were reciprocals of each other. Okay, there's a connection there. So if you notice that, that's a good observation. But really, we just need the first 5 terms. So right there, that was all we needed. I just wanted to keep that going and point out that little observation. Okay, example 5, last one. It says find the indicated term of the geometric sequence. So now they're going to tell us what n is. So we're still going to be using this equation, that a sub n equals a sub 1 times r to the n minus 1. And we're finding our 10th term. So if you want to do a sub 10 here, you can. You can substitute in the 10 for the n. They tell you your first term is 4. They tell you the rate is 3. And they want you to find the 10th term, so 10 minus 1. Okay, now we're going to simplify this a little bit. 4 times 3 to the 9th. 10 minus 1 is 9. Now remember, just like when we were doing those interest problems, you have to do that power first. So 3 to the 9th, you have to do that first. So you get 19,683 times 4, which is 78,732. Oh my gosh. So if you have a sequence that starts with 4 and you multiply by 3 every single time, your 10th term will already be 78,732. That's a fast growth rate. That's big exponential growth. Okay, let's try it for part B. Here we're finding a sub 8. So it's just written a little bit different now. Okay, so they're telling us right here, usually this is a sub n, and they told us we have a sub 8. So that means n is 8. That's what they're telling us there. All right, so I'm going to find a sub 8. My a1 term is -3. I'm going to put it in parentheses just because it's negative. And my rate is -2. Oh my goodness, you can have a negative rate? Sure you can. And then I'll have n minus 1, so 8 minus 1. So again, we're going to simplify this a little bit. -3 times -2 to the 7th. And then you'll have -3 times -128. Because again, we want to do just the -2 to the 7th. Make sure you do it in parentheses so that negative stays with the 2. The negative's getting multiplied 7 times as well. So since it's an odd exponent, you should get a negative number here. And then when you multiply this -128 by the -3, you get a positive 384. All right, so One more question before we go. How do you know that this sequence, 1, 2, 6, 24, 120, is not geometric? Remember, if it's a geometric sequence, it has to be multiplying by the same amount. So we go from 1 to 2, we have to multiply by 2. We go from 2 to 6, I'm multiplying by 3, and then by 4, and then by 5. So it's not geometric because you're not multiplying by the same amount. All right, so your homework for this evening is a worksheet. If you didn't pick it up in class, it is on the class website, so you can print it off. Use your notes as a guide so that you have that equation to use, and definitely show your work. If you have any questions, come on in and see us before school.